Hello, everyone, and welcome to today's webinar on the deployment of MicroNIR in a chemical production process. I'm Eleonora Mustorgi, LATAM and EMEA MicroNIR application engineer, and I'll be introducing this session. Well, today we'll explore the opportunities for real-time process monitoring with MicroNIR alongside Kode, a software development company specializing in custom solution through the application of machine learning and mathematical algorithms. So I'd like to introduce our speakers from Kode. Joining us today are Marco Calderisi, CEO and founder of Kode. He is a specialist and an expert in data mining and machine learning in general, and Francesca Sbolgi, a talented data scientist at Kode, specialized in developing data-driven solutions. Just a couple of technical information before starting the webinar. Please ensure your microphone is muted and your camera is turned off during the webinar. For submitting your questions, please using the QA section of Zoom rather than the chat section. And at the end of the webinar, we'll try to do our best to answer them within the time available. Any question will be not addressed live, will be answered in writing and sent to you by the end of the week. So this is not a problem. Immediately after closing the webinar, you will receive a survey. Your feedback is very important to us, and it is also important to receive the presentations and the webinar recording. So please to fill it. Let's start with a short presentation of VIAVI Solutions, the company behind the MicroNIR technology. VIAVI Solutions is an American company based in Santa Rosa, California, with a presence over 127 countries worldwide. We offer innovative solutions across two key business units. Network and service enablement, in which we focus on telecommunication, and optical security and performance, the OSP. Here we provide filters and pigments for optical security and performance testing. In more details, in the OSP, we can recognize 5 main sectors of interest. We focus on anti-counterfeiting with filters and pigments. In automotive, we offer critical technologies for ensuring the vehicle safety and performance. Moving on, consumer electronics, we are innovating with technologies like face and gesture recognition in smartphone. We offer solutions for government and aerospace applications. And finally, spectral sensing, which includes the MicroNIR product line, so miniaturized NIR sensor for field application, laboratory analysis, and of course, process monitoring and control in real time. A couple of words about the MicroNIR technology. The core of our devices is the linear variable filter. The LVF is a special bandpass filter with a wedge shape, which allows to disperse the light in according to the position. As you can see in the picture, the small dimension of the LVF allow to obtain very compact and robust devices without moving part inside. In this slide, you can see better the cross-section of our optics. As you can see, the linear variable filter is mounted directly on an in-gas detector in which each pixel detects a single wavelength coming from the light transmitted by the sample. The light source is ensured by the two tungsten lamps. The lamps rated for more than 40,000 hours lifetime, but in practice, we observe that they last much longer. So this is just the nominal lifetime. The fact that we have a moving part, of course, avoid misalignment, ensure a long-term stability and the 100% transferability unit to unit. We don't use fiber optics, so we have great advantages in terms of maintenance, and of course the MicroNIR devices are less sensitive to temperature variation. I would like to show you very quickly our product line. Here you can see our new 1700 EC, the new version of our historical device. This is a compact spectrophotometer thought to be used in academia or by our OEM customers. We have also the on-site W for field application. This is our portable device that can be used also with the mobile phone app. And for real-time process monitoring and control, we have two main solutions, the PATU due to the USB connection and the PATW, our wireless spectrophotometer to take under control complex processes in many different fields like the chemical, pharmaceutical or agri-food ones. In this slide, you can see the same devices in the ATEX version, so you can use them also in the ATEX environment, as you can see by the certification. And in terms of software, we offer with each device our MicroNIR Pro software equipped with a full chemometric package, but we have also the compatibility with other chemometric platforms as Unscrambler, Eigenvector, Synca, and Vector Director. For process monitoring, our process software are the OPC UA and DA to ensure a full system integration. If you prefer to work at the SDK level, you can use the Spectral Server, but we are also compatible with SynteQ, CPAT, and CamoPulse. So thank you for your attention. I'll pass the stage to Marco from Kode, and we'll be back for the QA section at the end of the webinar. Thank you so much.
Good afternoon. My name is Marco Calderisi, and I'm the CEO of Kode. We are software company which is specialized in transformer in developing tailor-made solution based on data and on statistical models, especially the artificial intelligence techniques. We are based in Pisa and Cagliari. We are more or less 20 people, all passionate in the path analysis in general, going through from data visualization to deep learning, computer vision, and LLM techniques. Our target are mid to large company. The only requirement is they have an internal IT department which equipped with some data collection system. We do two kind of services. We develop custom projects, but we also sell plug-and-play paradox. They are very, very specific for certain application. In order to do that, we have developed an internal data science framework, which is called Princess, that we use to develop custom projects, but also to make the tools, the software tools that we then sell. One of those tools is called a spectralizer, and I will give you a quick introduction of the software, and then Francesca will show you how we have used it on practical case. This is a software that can be used to analyze any kind of spectral data. It is thought mainly for NRI spectra, but it can also be used for XRF, Raman, or fluorescence, or magnetic resonance, and so on. We thought about that this software is a sort of bridge between the process operator and the chemometrician, anywhere in the world it could be. I mean, is a sort of link between what you do in your lab when you're analyze your sample, or maybe for the first time you produce your calibration models and everything else, and you have to deploy them in production in order to be used on your process line, or maybe also in your laboratory. And this is the same tool, the same instrument. So you produce the model, you save it, and it is available, immediately available everywhere else you may need it. So spectralizer can be used to create, manage, and maintain calibration model, and also to control the production process in a real-time manner. And it can be used in an industrial process, but also in a laboratory, in a research lab, for instance. It is made of different modules. The first one is the data integration or ingestion system. Is an interface that you can use to upload your data. You can do it by CSV file, or it can be connected to your database. You can from this interface you can select the spectra that you are interested in, decide if you have a regression or classification problem. You can adjust your spectral range. You can also check for the applicability domain in order to observe if there are some samples that are a clear outlier, so you can remove them. But you also check for the value distribution of your target variable. And also in this case, you can see if there are some samples that have abnormal values. So you don't want to put them into your calibration model. Once you have selected the samples that you can use, you want to use to produce your model, you produce the model. And one very, very interesting feature of this software is then you can choose which are the processing step that you want to check. And then you can, with just a couple of quick, the algorithm search for the best preprocessing techniques, concatenation and selection in order to give you the best model performance. So you don't need to run, I don't know, 10, 20 different models, but you just choose the preprocessing step and it does all by itself. So once you have the perfect model, you can use it to fit new data and in order to check it even better than before. One other very, very important aspect of the software is that you can do a sort of model ops. I mean, this is a tool that you can use to manage your model, your calibration model, in order to see if they are still performing well, if you need to retrain them, or if you just this is also a normal repository of models that you can choose, which is the one that you need at that moment. And this is the interface for the real-time monitoring that you use in your process. And the nice thing is that this interface, you can call the model that you have developed using the other part of the software. So it's just the same software that is in your internal cloud, and you can use in the lab and also in the process. And from this interface, of course, well, this monitoring can run in a really automatized way, because you can also take some data, some information from the, I don't know, your PLC or the mess or everything else you may have in your plant, in order to understand which is the batch of products that you are producing, or the what is in that moment into your process. This is something that, of course, is related only to spectral data, but as long as you put it in your production process, you may be interested in doing something more. And then, so you can, to do that, you can spectralize is, you can integrate it into our another software that we've done, which is called Factory, which is a software that let you put pattern visualization and machine learning and everything else into your process. Why you want to do that? Because you want to do process control or optimize your process. You want to, I don't know, control raw material that are in input to the process. You want to forecast the quality of your product, to do predictive maintenance, energy saving, or calculate your carbon footprint, or whatever. The infrastructure is very, very, very easy, because the spectralizer, which is the green part, is directly connected to the spectral probe and to any data source that you may have in your plant or in your lab. It can be used in two different configuration. One is the ready-to-use one, which is you just download it and install it anywhere you want it, and you're ready to upload your data and do everything else you may need. And otherwise, we can customize it in order to make it more usable in your process. We can add some feature or anything that you may require and that maybe you don't find in the ready-to-use version of the process. So the use cases are more or less these two. I can use in the production line. So it's a very simple and user-friendly interface for operators in production, and is very connected to the NIR instrument, for instance, but it can also be connected to the lab where you produce the model, and to ERP and everything else. Or otherwise, you can use it in an analytical lab, so you can deploy your model and then recall them very, very easily and quickly when you need them. So we say that we have one platform, many location, because the spectralizer system usually is where is the production process or the lab, but you can access to the system from anywhere else in the world. So I mean, I can work with a factory that is in Brazil, let's say, and I can do it from my place. I can produce the models, the calibration model, and they are immediately available in a production plant in Brazil, let's say. Of course, it can be used by the client data scientists, or we can use them and help our clients, or we can also do some training. So this is all. This is an overview of on our tool, and I will give the floor to my colleagues, Francesca Sbolgi. They will talk about a practical application. Thank you.
Thank you, Marco, for your introduction. I'll be sharing my screen. Good afternoon, everyone. I'm Francesca Sbolgi, and I'm a data scientist in Kode here in Pisa. And today I will be talking about a use case of spectralizer applied in the agrochemical field. So just for reference, the company that we will be talking about is produces huge batches of agrochemical compounds that takes about 30 minutes for the raw materials to become the final product. And they produce a set of different products, and of course the production is affected by a set of different variables, such as the weather conditions, the quality of the raw materials, a set of different settings in the machine. And they were doing some quality control analysis, but only in the lab. The lab analysis, of course, are very accurate, but they take about 2 hours to complete. So the problem is that they can have control over the quality of the product only 2 hours after the product is actually been produced. So our challenge was to minimize out of standard products. So to give them more control over the quality production, both in time of timing and of frequency of the control. So the timing is important because you need to be able to understand the conditions of the system as soon as something happens. So they have a way to understand if there are some production drifts, and be able to understand if there are some corrective actions that need to be taken in order for the production to be taken back under control, but also in terms of frequency, because the lab analyses are quite expensive and you cannot do them too often. But using a spectral probe and the NIR probe in particular, the cost of an analysis is almost free, and you can do them more often and then check the quality of the product, not only of the huge batch of product, but of every single unit that will go on the market. So our solution was to give them process control system that can be used both by the operator in the plant in order to be able to see the data in real time and understand what's going on in the production and see if there are any problems that needs to be taken care of, but also from the data analyst point of view, so that he has a way in the lab to create in an easy and friendly way some multivariate statistical models that are customized for every product that they need to make, and they have a way to be able to, in an independent and autonomous way, to recalibrate those models to accommodate new data or variations in the system. All of this, of course, is present in our software Spectralizer. So we gave them a custom version of Spectralizer that can read the data directly from VIAVI's MicroNIR, and that can be used both on premise by the production operator to see data in real time, but also by their chemometrician that was trained by us to be able to build complex models on this data. We wanted to show you the workflow that we followed for this project and the workflow that we follow in general for this kind of problems. We can summarize it in these bullet points. So first of all, we have an active discussion with the client in order to understand which are the data sources available, which data can be extracted from those data sources, and of course, which are the target variables that help the most understand what's actually going on in the production. So that could be some indicators of which actions need to be taken to control the production. Once the variables and the data is decided, we can start with the design of the service infrastructure that has the main purpose of collecting the data and storing that in a neatly way, then elaborating and producing a different set of computation on this data, and finally have a way to visualize the results of the analysis. Once we have the infrastructure, we can start with the actual development, both of the backend and then the front-end part. The backend is the core of the computation, so it's where the data is pre-processed, so it's cleaned, it's cleaned from the outliers, it's modified in order to accommodate better the models that need to be done, and of course build the models itself. The front end is usually made of, first of all, a couple of wrappers that show the preliminary results of the analysis, so that we can understand if the data that we are collecting is actually useful for the results that we want to obtain. And of course is made of a final dashboard that is connected directly to the data and that can be used to see the data in real time. Finally, there are two phases. There are the test and validations, and finally the final results. So in the test and validation, we test both the results of the analysis of the computation and of the system stability. So we correct if there are some possible bug fix to be done, or if the models need to be recalibrated. Once the system is validated, we share with the client the final results. In this case, from the discussion with the client, we understood that the variable that was most important for them to understand the quality of the product is the humidity level. And they told us that they need the humidity to stay between 105 and 207% in order for the quality of the product to be considered of high quality. And they also set us an acceptable prediction rate error. That means that a prediction is considered accurate if the error does not exceed this threshold. Regarding the infrastructure, we can identify three main parts, which are the client infrastructure that was already present in the plant. Then there is VIAVI's probe and the OPC UA. The probe was installed directly in the plant, while the OPC was installed in their servers. And then there is a spectralizer, which is a set of services that were installed in their servers, so that all the data and information that is protected under their network. What happens in practice is that a bit of sample from the production is automatically diverted from the production into the lab, where a conveyor belt takes the sample under the spectral probe, and they can use the PLC to operate the probe, so to start and stop the acquisition of the spectra. The spectra are then visible on the OPC, and from there we can start collecting the data, storing it, doing some computation, and then finally show the predictions. We wanted to give you more in detail information about the backend, so of the models that we developed. So the NIR spectrum is, of course, a very powerful tool, but it's not so useful without a model built on that. What we did was to build two types of models. The first is an applicability domain models that has the purpose of identifying outliers and cleaning the spectral acquisition. So without a human supervision, we can take the whole spectral acquisition and clean from the spectra that are not useful for the analysis, maybe because there is not enough sample on the conveyor belt, or if there are any other problems. The applicability domain understands if the spectra that we're reading is compatible with the ones that we used to calibrate the model. And once the spectra are filtered, we can use the calibration model in order to actually predict the target value and deliver it to the operator. As for the front end, Marco already showed you what are the functionalities, so we'll not go too much in details. We'll just say that we gave them two different tabs of Spectralizer. This is the model management tab that gives the chemometrician the ability to either select an existing model that was previously trained or to build a new one. So selecting the data that you want to take, deciding the types of preprocessing to be made on the spectra, and then see the results of the model. Once the model has been saved, the operator can use directly the results of that model in the real-time tab that is kept has been kept simple in order for the tab to be very accessible. So it only has the real-time values of the target value, in this case the humidity, and the alerts that may arise from the computation, and a simple trend of the target variable to understand if there are some possible drifts in the target variable. Regarding the test and validation, we can divide the testing in two parts. The first is centered around the model. So there is a phase where we try to collect as much new data as possible, and we recalibrate the models in order to understand if they actually deliver the results that we expect, and we try to make them more robust to handle even more data. Then there is the real-time testing that tests the conditions of the system, both in good conditions, so it just stress tests the data stream, but also it tests the failure scenarios. So it tests if there are some problems with the acquisition, if a model for a particular product is missing, or if there are, for example, insufficient sample in the acquisition. We wanted to show you just as an example the results that we obtained. In this case, we selected the two main, of course, anonymized versions of the main products that they produce, And here in this plot, you can see the real value compared to the predicted value of the humidity. And as you can see, we obtained good results that stays within the acceptable rate of error that we set. So that was it. Thank you for your attention. And if you have any questions, I'll be happy to answer them in the Q&A section of the presentation.
Thank you so much, Francesca. So welcome back to everyone for these Q&A questions. So I ask all the speakers to turn the camera on in order to answer to the questions. We have an interesting one from Ugo. Thank you, Ugo. The question is, how much is the application ready to be applied to other industrial sectors? So I don't know if Marco or Francesca.
Well, I can say that the application is already ready because Factory I is currently in use in other plants, and also Spectralizer is a new one. The first official release will be released at the end of this month, but it is already in use in this place, and we are developing another application for another production process, which is completely different. So yeah, I can say that we just need to customize a little bit the tools in order to better adapt to your process, and then they are ready.
Perfect. Thank you, Marco. So I have a couple of questions for you guys because I think were very interesting presentation. So Francesca, I would like to ask you which is the protocol you generally follow to optimize the calibration, and which is your experience in terms of maintenance of the calibration models along the time, because we every time talk about the maintenance of the devices, but also the model require a certain maintenance. So I'm curious about that.
Yes, of course. So regarding the calibration of the model in the preliminary steps, so where we calibrate the models, we usually try to look at a couple of different errors, such as the R squared, the RMSE, and so on. So this is a kind of a back and forth with the client. So if the models are not producing the level of accuracy that we want, we try to understand if there is a way to collect more data. An important part is to have a good range of what can actually happen. So to have a different set of samples that are enough descriptive of the population of what can actually happen. Usually, if enough data is collected, the models starts to behave as expected. If not, we can try with different types of preprocessing of more complex models if required. While once we, I would say, once the application is in production, one thing that we were very interested in being able to do is to let them be able to recalibrate by themselves the models. So as you said, is a problem that is very frequent that once you release the product, everything is working, and as time passed on, you need the expertise maybe of a data scientist in order to recalibrate and adjust the model. But in this case, we try to make the application as simple as possible, so that after very basic training, a data scientist, a chemometrician that usually is already present in the company can update and recalibrate the model by itself. So it literally takes 5 minutes to calibrate a new model. So you can do some experiments and find the correct settings in order for the prediction to be accurate.
Perfect. Thank you for the clarification about that, Francesca. I have a more general question for you, Marco, because according to your experience in industrial data analysis, in your opinion, which is the state of using process data for process optimization, for analysis to detect fail and outlier right now, and which are in case the challenges you see in implementing this kind of control?
Well, thank you for this question. I mean, I think that today everyone collects data. Maybe also in a very thoroughly way, but there is still well, you cannot just visualize them. You cannot just watch them. You need to try to extract some information from them. And today it's very easy to collect data. I mean, thousands of numbers coming from hundreds of parameters every second. But if you don't have some proper tools to analyze them, it's very, very difficult to understand what they mean. And so the risk is that after a while you just stop collecting them or looking at them. So in my point of view, I mean, there is still a lot to do in the data analysis part of the job. I mean, everyone collects number. Now it's time to extract some information from those numbers, and there are lots of tools and instruments, and there are many things that it is already possible to do in order to optimize the process, but also, I don't know, to save some energy, reduce waste material. I mean, there are many business goals that you can easily achieve nowadays. In my opinion, yeah, there are just a few places where data are really exploited, and there is much more that we can do. I mean, yeah.
Perfect. Thank you very much for your insight in this. I see we have a couple of questions. One from Paolo Manes is asking if are you aware of economic benefit practically gained by users in general and from chemical industries which eventually exploited the proposed innovation?
Yes, this is a very a very important point, because of course everyone wants to know, okay, I did that, but which is my benefit in introducing, I don't know, let's say artificial intelligence in general, machine learning in general in my process. And it is very difficult to answer in a general way, because without having a proper knowledge of the system. Because I think that maybe I can say, okay, you will have 5% of reduction of your scratches, waste material. But those 5% is worthy €1 million or €1, because in that case you're not interested at all in going a lot that way. Maybe you are interested in something else. So I think that this is a very right and important question, but it must be put in a proper context, which is different from place to place. So you can have a very different business goal, and then you can say, because of course you can improve your process, because knowing your data lets you improve your knowledge, your know-how about what you're doing. But of course, you have to see if what you are improving is really what you really need.
Perfect. Thank you, Marco. We have a last question from Ana Alves. She asked if we are agree with her in saying that the more difficult things in obtaining good models is the accuracy and the reliability of laboratory data. I personally agree with that. Of course, NIR is a secondary technique, so it needs to be calibrated on a reference method. So the precision and the accuracy of the wet chemistry and reference technique is crucial. If Francesca and Marco, you want to add something to that?
Let's just say that I was saying before that we need a lot of data in order for the models to be accurate, but for NIR, we don't have so much variability that it's impossible for the lab in order for it to produce enough data. Usually we can use the analysis in the lab that they already made along the years, or they are producing right now, and use that to calibrate our models. So once the application is in production, they can continue doing the lab analysis they were doing before, or hopefully do a little bit less, because they have other tools for to do an estimation of the target variable. But of course, you always need a little bit of results from the lab in order for the models to stay accurate and understand if there are some deviation in the production, because for example, there are some production that are very affected by the season. So usually there is a seasonality in the production that needs to be taken care of, and the models can address that, but they need also some I would say like confirmation of what is actually happening. So having some confirmation from the lab that they are still predicting with good accuracy. So of course the lab analysis is fundamental, but this tool is an aid in order for the lab analysis to be required less, and if not less, to have more control over the production. So they are two sides of a coin. Let's just say that.
Thank you, Francesca. So I think we have other questions. So I think I can thanks everyone for joining our webinar. And I would like just to remember that immediately after closing the webinar, you will receive a survey, and by the end of the week, you will receive the presentation of the speakers and the recording of the webinar. So thank you so much.